All right, good morning, everybody. It's great to be here in San Diego in the basement. It was nice to be up on the roof for a little while, but now we're in the basement having a blast, right? Learning all this fantastic stuff. My name is Ritch Selfridge. I'm the Director of Engineering at Amphenol Aerospace. Amphenol's all about interconnect systems, interconnect structures. And I'm going to give you a little presentation on intelligent interconnects with integrated electronics. So I have a dream, and my dream is that interconnects will become intelligent, autonomous data and power delivery systems. So I show a little image of some electronics embedded inside of a connector. And I look at systems that are out there today available to every consumer, our cell phones, smartwatches. They're just loaded with sensors and electronics. So why not integrate some of this great technology into what's traditionally been a passive interconnect structure? So one way that I look at this opportunity is I want this power and data delivery system to take some burden off of the box designers. You know, the box designers have specific functionality that they're trying to achieve, whether it's analyzing threats from incoming missiles, radar analysis, whatever it might be. That's the primary function of these boxes. And I've pictured them here as factories. So these little factories, they need power, they need data to come in, and then they need to output data to the warfighter, to other systems, other factories. And I show the little trucks here of power coming in and data leaving to kind of represent what happens in a normal factory. Most factories now, most companies now rely on third-party shipping companies to move their products, to receive raw materials. They don't depend on their own delivery fleets. They don't worry about road construction issues or maintaining fleets of vehicles. They depend on a third party. And I think interconnects can be that third party and go beyond the passive structure that everyone has been kind of assuming for most interconnects and move into a new world. So the value proposition that I see with this kind of development is, let's see if I can do this. First over here, weight savings. And obviously, for most flying platforms, that's a huge, very important factor for the systems themselves. And the way that we would facilitate that in an intelligent, autonomous interconnect system would be to convert. You've heard a lot of different things about converters in the various presentations, from copper to fiber optic. So you start eliminating the need for shielding and other heavier types of technology to accomplish the goal. In addition, you can start using the intelligence that you're picking up from the interconnect system itself to maybe change some of the parameters of design of an interconnect structure within a platform. And I'll get into that later. The middle one is the big one that I mentioned before, focus. I really want to permit that the box designers focus on their primary mission for that box. Not worry about moving the data and receiving power from the platform, but focus on what they need to do, their core competency. One of the other things that can happen with an intelligent interconnect system is the ability to do some technology recycling. So a specific box gets designed for a specific platform that had a set of parameters that went with it as far as protocols, power levels, all that kind of stuff. As opposed to developing a new box, that same box could be put on a second platform as a fully qualified unit, but allow the interconnect structure to then manipulate, change protocols, do whatever it takes to facilitate that box transitioning from one platform to another platform. Down in the lower left-hand corner, if I can do it, this is fascinating. So health monitoring. Health monitoring of that interconnect structure. There's an opportunity to do that. That can help with maintenance, help with, even during the mission, maybe some parameters that you want to change during the mission. And finally, the big dream is to have an intelligent, autonomous interconnect system that can actually heal itself, that can detect failures during the mission, whether they're induced by enemy fire or they're induced by some other issue that came up during the mission. So that's the ultimate dream. So here's my intelligent interconnect roadmap. It's pretty basic. I'm staying at a pretty high level. But down in the lower left-hand corner, we start out with media converters. You've heard lots of presentations that have been talking about media converters. So obviously, that's a relatively mature technology. I'll get into that a little bit more. But that's the first part of the pathway here. Then rugged network switches, integrating the rugged network switch into the interconnect system, the interconnect structure. Next, we have sensor integration. So we can start monitoring what's happening in the interconnect structure during the mission. And then I show a smartwatch here, sensor data processing and storage. So instead of putting the sensor data into a box and again distracting the box manufacturer from their primary mission, why not let the interconnect structure do that itself? Provide it with the intelligence to start taking that data, analyzing that data, and utilizing that in a different form. And then I also show some energy harvesting. So these smartwatches, these low power processors that we have come to love, don't require a heck of a lot of power to do their job. There's a smartwatch out there from Matrix that runs on body heat alone. So there's some very neat possibilities to use energy harvesting from the platform itself to power up this ability to process the sensor data and store that data such that it can be used either during the mission or between missions and not be a parasite, not pull from the platform and demand that the platform push more power out to these places. You can put these things in remote locations that don't need the power, or there's maybe it's inefficient to get the power out to those remote locations. And all that kind of starts to roll up into the ultimate intelligent autonomous interconnect system. So I'll start off with media converters. We've been doing these for years, as have many people. Down on the bottom left, I can't quite get this magical thing to work, is our Vita 46 connector with the Vita 66.5 light connects. That's a media converter. You're converting from electrons and copper traces to photons in optical fibers and back. That's a relatively simplistic media converter, but obviously there are huge advantages to that media conversion, and density is one of the biggest ones. These other media converters are converters that we've done for numerous applications, where maybe not only you're converting from copper to fiber, but you're converting protocols. So again, to facilitate some of the transition from maybe one platform to another platform without the need for heavy-duty requalification. Next, rugged network switches. So taking the same network switch guts that we depend on in the office and home environment, ruggedizing them, packaging them into the interconnect structure itself. So there's opportunities to do that and not burden the system, burden the box with the need to do this switching function. Sensor integration. We've been integrating sensors into connectors for years, but typically it's at a specific request of a customer. And that customer is then going to take the responsibility of taking that data back and analyzing it and manipulating their system, their box, based on the data. The miniaturization of sensors is just phenomenal. That's why we have all these cool smartwatches and capabilities with our smart devices. Heck, you can even get your EKG done with a smartwatch. It's pretty fascinating. And that's only going to continue. The commercial market's going to drive that. So you've got temperature sensors, you've got accelerometers, you've got pressure sensors, Hall effect sensors. All of these different devices can be packaged into the interconnect structure to observe what's happening in that interconnect structure and utilize that data in various ways. I talked a little bit about energy harvesting. Here's the matrix thermoelectric converter. Pretty phenomenal that you could run a watch off of body heat now. And it's not just that the converter is more efficient, but obviously the processing, the load of the processor itself is super light. So that something like this kind of technology can empower a processing node without any external power needed. The devices on the right, on that penny, are vibrational or dynamic types of devices that scavenge power as well. Piezoelectric strips on cantilevers that can generate power, albeit tiny, but they can generate power from the energy that's on the platform itself. Then you need to capture that power, maybe with an ultracapacitor or something like that. And now you can have this autonomous data processing system for sensors for interconnect structure, interconnect system health. The next step is to strap a smartwatch on your connector or your cable, right? Not exactly, of course. And we all know that smartwatch size is kind of based on interfacing with people. You want to be able to actually see what the heck is on the smartwatch, so the display is a large factor in why smartwatches are as big as they are, as well as the batteries for the smartwatches. But the intelligence in there that's doing the magic, that's running all of these operations and sensing the data and analyzing the data, that's really pretty tiny. And that can be incorporated into an interconnect structure in such a way that we can capitalize on this type of technology. So all of those things rolled together start to form this opportunity for intelligent autonomous interconnect systems. One of the first roles that this type of system could play is in data logging and reporting. So perhaps during the mission, you've got these sensors, they're picking up data that's being recorded by the smart watch processor and being stored. And then when the mission's over and you're back on the tarmac, the maintenance crew can come in and actually analyze all of these data points on the interconnect structure. So if there was an issue during the mission between box 1 and box 2, instead of having to check all those links between those two boxes, they can focus their efforts. Maybe it's connector J6 on bulkhead 3 or something like that. So less downtime by utilizing this type of data that can be collected. Autonomous data and power management. Now this is where we kind of drift into the far outness of possibilities. I think about, especially with power, the harnesses in a platform are typically dictated by number of conductors in the harness, type of insulation, are they shielded, are they jacketed, what altitude are you going to be at for a flying platform, all sorts of things that derate, so you have to pump up the amount of copper on the platform to deal with that. I'd love to get to the point where we could instead push those boundaries a little bit further, because all those bad conditions don't typically happen simultaneously. But the platform has to deal with the potential for those conditions to occur. But if you're collecting data, if you have an intelligent, autonomous interconnect system, it could start making decisions and being designed with less copper in it. But maybe, let's say for a power line, you go down to a smaller gauge because most of the time you won't have to push the envelope on the amount of current flowing through that would create like a power loss due to the resistance. But with a smart interconnect system, you could be detecting the temperature rise. You start to detect deviations from what you think are acceptable. And this interconnect system, this interconnect structure could be empowered then to start using spare lines, start busing lines within the interconnect structure to drop that resistance of that overall circuit. So those are kind of exciting things that I see out there. And then the ultimate dream, I mentioned it before with the picture of the chakras or whatever you want to say about the human body there, is autonomous healing and repair. This is the ability for this interconnect structure without any external efforts from the boxes, from the avionics system as a whole, to diagnose itself. And let's say it's a rotorcraft and it's on a mission and it gets hit by a couple bullets and it happens to go through one of the harnesses of the system. In an autonomous interconnect structure, it'd be really far out to let that structure then diagnose that there's an issue with this link and then come up with a way to work around that particular issue with the link. Come up with alternate routes to get power or data to the locations so that the mission can continue and we keep the warfighter safe. So that's kind of the big picture that I'm presenting here. I am excited to be here and thank you for your attention. And I say, dare to dream.